Hello and welcome to this presentation. In this session, we will talk about the Oracle MySQL Database Service. My presentation about the MySQL in the Oracle Cloud is basically divided into two areas. One of them, this one, is about the MySQL Core Database Service, and the other presentation later on is about an extension to the MySQL Database Service called MySQL HeatWave, which is all about analytical workload. My name is Carsten Thalheimer. I'm located in the area of Frankfurt. I'm a so-called solution engineer. I'm working toward a MySQL GPU within Germany since a couple of years already. And especially since last year, I'm concentrating on the MySQL Database Service. Before we start, I need to start with two logistical slides. I'm sorry for this, but one of them is rather boring. There we are, that's the boring one. Oracle is a US-driven company listed on the NASDAQ. Therefore, I need to make sure that this safe harbor slide is included in my presentation deck. Everything what I'm going to tell you about the MySQL Database Service and about upcoming features and future is not a commitment. It is probably our plan, but plans may change at our discretion. Or in other words, I can be completely wrong here and can tell you fairy tales, but this is of course not my intention. I want to be as accurate as possible. That's the second logistical slide, which is probably more interesting. In case that you want to test the MySQL Database Service, the HeatWave service, or any other Oracle Cloud services, you can go to this site, cloud.oracle.com/try-it, and you can request a $300 or 30 days voucher. After the $300 or the 30 days, the account will automatically be converted into a so-called always free account, which means that you can run a couple of services for free for an unlimited period of time. So for example, a couple of compute instances without paying for it. In case that you're interested in a bigger promotion, well, in case that you get in contact with an Oracle colleague of mine or with myself, my email address is mentioned here, we can request a $500 promotion for you, so $200 on top of the $300. And the interesting thing here is that it's even easier and faster to get access to the Oracle Cloud, because with the $500 promotion, there is no credit card validation or something included. The agenda. Well, this is a presentation, an entry-level presentation for the Oracle MySQL Database Service. It's mainly divided into three areas: the Oracle Cloud Infrastructure, the Oracle Cloud, the MySQL Database Service, and the demo. We can talk about hours for every single of those topics. In case that there are questions, don't hesitate to ask the question right away in the Q&A session or to get in contact directly with us afterwards. Before we start to look at MySQL, I'd like to spend some minutes on the Oracle Cloud. Background here is that nobody wants to run a database because it is funny or it is cool. We want to run a database because we want to serve data to an application. Whether this is a simple application like WordPress or any other of the content management systems, or a more advanced environment like, for example, applications in a Kubernetes environment or in an Oracle directory domain, really doesn't matter here, right? In the Oracle Cloud, we've got the concept of realms. What exists in one realm is not known by others. They are isolated. Each realm stands alone based on regulated market requirements. Today, we've got 4 realms. Realm 1 is the so-called commercial realm for customers. This is the interesting one for us. And let's assume that this, what you see here, is one of the realms. Realm 2, 3, and 4 would probably look the same, but they're not that interesting for us right now. And Realm 2, 3, and 4 are reserved for governmental customers in the US and in the UK. The commercial realm is available in around 25 regions across the world. In this example, we can only see 3. And Oracle opens around a region more or less on a monthly basis. We've got Oracle regions already in all parts of the world. We see them on the next slide. We've got 2 categories of regions. A region has either 1 or 3 availability domain. In this example, we've got 3. Let's assume that that's Frankfurt. An availability domain is basically a data center. So yes, in Frankfurt, we basically have 3 independent data centers. Let's call it Frankfurt North, South, and West. Within a region, we directly connect those availability domains with a very high bandwidth, which guarantees low latency. It is possible for you to build replicated, high available systems in multiple availability domains. That's something which we'll discuss later on when we talk about MySQL HA. In an availability domain, we furthermore have the concept of so-called fault domains. Each availability domain has 3 fault domains which provide anti-affinity. This means that we've got distributed instances which are not on the same physical hardware and are even not connected to the same power segments. We talked about the Oracle regions. Well, that's the status as of today. The red ones, those are the commercial regions which are already up and running. You can use them already, whereby the white or the gray ones, those are the ones which we are planning to go live within the next couple of months. Keep in mind my safe harbor statement from earlier on, but I think it's fair to say that we will go live with those regions very soon in, again, the next couple of months. In some regions, we offer a dedicated interconnect between the Oracle and the Azure cloud. So in case that you're running the application or the database in one or the other data centers in the Microsoft Azure data centers, you will have a very, very good interconnect in between them because they are directly linked. When you sign up for the Oracle Cloud Infrastructure, Oracle creates a so-called tenancy for your company. This is a secured and isolated partition within the Oracle Cloud Infrastructure where you can create and organize and administer your cloud resource. It's again completely isolated towards other tenancies. In the tenancy itself, you can build so-called compartments. A compartment is basically a collection of related resources which helps you to isolate and to control the access to the resources in the compartment itself. Each resource belongs to a single compartment, but resources can interact within other resources in other compartments, and in fact, you can even move them in between the compartments. Compartments is basically a collection of related resources that helps you to isolate and to control access to those resources. For example, you as a global administrator of a tenancy can make sure that an administrator of a development compartment cannot access the resources of a finance compartment or the other way around. So far, you've probably seen similar concepts like in other clouds. So what's different with the Oracle Cloud and why do we call it Gen 2 Cloud? Well, we can have a long discussion about security and why security as a key cloud principle has significantly improved. But the main difference is the so-called off-box networking concept. Most other clouds use traditional network and I/O virtualization technologies from the underlying hypervisor. That is maybe sufficient to satisfy single tenant approaches and virtualization for on-premise needs. But for the cloud, it's probably a bit different. For the Oracle Cloud, we use a technology called off-box networking and I/O virtualization. The hypervisor does the job for the CPU and the memory virtualization, no change here, but we move out or we off-box the network and the I/O to a technology called via technology called SmartNIC, which isolates and virtualizes the network by the underlying hardware and software from the host and not from the hypervisor anymore. This guarantees the best network and storage performance, including service level agreements. And this is the part which is more or less unique to the Oracle Cloud. And I would say that this is the main difference between the Oracle Cloud and a lot of other cloud vendors out there. The MySQL Database Service, or short MDS, is a fully managed MySQL service. It's very easy to use. It's basically the powerful union of the Oracle Cloud Infrastructure, Gen 2 version, the Cloud Infrastructure, which we discussed before, and the MySQL Enterprise Edition, which you probably already know. It's fully compatible with the on-premise MySQL 8 version. In fact, the binaries which we're using on-premise and the binaries which we're using in the Oracle Cloud is more or less in fact the same. So this makes it quite easy to migrate the data from on-premise to the cloud, or in case that you want to migrate from on-premise to the from the cloud to on-premise, that's possible also. In fact, we are using the latest security fixes. So hopefully you're using 8.0.24, and this is the version which we're using in the Oracle Cloud as well. The product itself is 100% developed and managed by the MySQL team as well. So there's only one MySQL team within the Oracle Cloud, and this team is responsible for all of the MySQL versions. The service includes 24/7 complementary Oracle Premium support for MySQL as well. So in case that you are aware of the Oracle MySQL support product, which you get as part of the Oracle Enterprise Edition, that's the same what we are offering in the Oracle Cloud as well. The service itself starts at $43 a month, and this would be the equivalent of one OCPU, 8 GB of memory, and 50 GB of disk storage. In the Oracle Cloud, you also have the option of having an on-top service, which is called MySQL Database Service and HeatWave for analytical queries or for analytical approach. That's something which we discuss in the next presentation. In earlier slides, we talked about the concept of tenancies already. And you probably remember that tenancy was quite a secured concept, and it is quite an isolated concept. So how are we doing the MySQL Database Service, and how does it run in the Oracle Cloud? So basically, the MySQL Database Service runs in its own internal tenancy, the MySQL tenancy, which has a very restricted ingress-egress policy that protects the database from any unintended access. You cannot get access to the underlying operating system or even to the virtualization level, right? That's not possible. The only way you can access the MySQL service itself is either via an SQL connections based on port 3306 or whatever you specify there, or 33060, or you can access the MySQL service to manage parts of the MySQL service via a so-called API, which is responsible for the execution of several administrative tasks. Basically, you access the MySQL service, which is controlled by the control panel, and it's used by the software agent. So when we look at the MySQL database and when we look at the available shape, so what's possible basically, right? So let's have a look at the available shape sizes for the MySQL database service. Today, we only offer fixed AMD CPU shapes with either 8 or 16 GB of memory. We are using AMD EPYC CPUs only. The amount of OCPUs also specified the available network bandwidth. Per OCPU, we'll get 1 GB of network bandwidth. The smallest shape today starts with one OCPU and 8 GB of memory, and the biggest shape which we offer is 64 OCPU and about a terabyte of storage. Storage starts with 50 GB of storage and ends with 64 terabytes of storage, which is the maximum InnoDB table space size. The storage size has an impact on the IOPS as well. Up to the size of your data storage, the backup is for free. In case that you would like to get an understanding about the potential cost impact of the MySQL database service, I would recommend going to this page, the Cloud Cost Estimator. Just search for the MySQL database service offering and then fill out the values, number of instances, number of days you want to run it per month, and so on and so forth. And you get an estimate about the potential costs. In this example, one OCPU, 8 GB of storage, and 100 GB disk storage, so not the smallest possible option, you will end up at about $45 per month. So now that we talked about the basics of the MySQL database service, let's have a look at some specific areas of the MySQL database service, and let's look into the technology a bit deeper. So we talked about the Oracle Cloud Infrastructure and some of the key concepts, and you will probably in my next section, the MySQL Database Service, recognize some of the stuff which we already discussed. Let's continue with the MySQL Database Service now. The first thing what we will discuss is the external or the public IP address of the MySQL server. Well, there is no, so we never expose the MySQL server endpoint to the internet. You can still use the MySQL database service in a public and in a private network, but then again, we never expose an endpoint to the public IP, and this is because of security. We know that other cloud providers do this, but we decided to not do it because of certification and of security. You can, of course, still access the MySQL database service, but there is an extra hop, there is an extra solution what you need to do. So for example, for the encryption and for the authentication. So you can use a compute instance or a bastion host, for example, and you can use this as a kind of a jump host solution. So before you can access the MySQL database service, you first need to do an authentication based on SSH or another method. And then from this bastion host, you can access the MySQL database service via the normal MySQL shell or via the normal MySQL client. You can, of course, use also the MySQL workbench, which, by the way, provides SSH tunneling. So with the MySQL workbench, it's rather simple, but then again, the approach is basically the same. The most straightforward solution, and this is the one which we basically support or which we basically recommend here for security, is to use VPN. And as I said earlier on, there are various VPN solutions which you can use from an Oracle Cloud perspective. You can use IPsec or you can use OpenVPN or even other VPN solutions. Let's have a short look into replication. Replication is probably one of the most used MySQL features in general, and we do partially support replication in the MySQL database cloud as well. You can run an external MySQL server and you can replicate the data from there as a source via inbound replication to the MySQL database service, which acts as a replica. We call this inbound replication. The main topic here is that you need to establish a connection between the outside MySQL service and the inside MySQL database service. In this example, we are using again VPN. There are various ways on how to achieve the connection, but VPN is probably the most secure and the most straightforward way of connecting an outside instance and an inside MySQL database service. The source server, in the past we called this the master, can be anything which supports MySQL and which supports GTIDs. Whether this is another Oracle region with another MySQL database service or another cloud vendor or even an on-premise version with MySQL, it really doesn't matter. It is a product from MySQL database service and it's very easy to use and to set up, and we even provide GUIs for the easy configuration of this technology. Another interesting topic about the MySQL database service is the data migration. You can migrate any MySQL data from an outside instance, and you can easily migrate this data to the MySQL database service. Whether you're migrating the data from an on-premise MySQL server or whether you want to migrate the data from one of the other cloud vendors towards the MySQL database service is technically not really a big difference. The main thing, what you need to look at it, is how you technically connect our migration tool and the source database. For doing the migration towards the MySQL database service, we are using the so-called MySQL shell. The MySQL shell was introduced a couple of years ago and evolved a lot in recent MySQL versions. Especially with the MySQL version 8.021 from last year, we added some new cool features to easily dump and load the MySQL data. This is dumped in parallel threads and rather fast and efficient. Let's have a look at the necessary steps for migration of a database. In this example, from one of the other cloud vendors or one of the on-premise MySQL versions. As said before, technically, this is not really a big difference. The first thing what you need to do is you need to create and to prepare MySQL object storage. That's something which you can do in the that's something which you can do in the OCI Cloud, or you can do your scripting as well. In the second step, we then connect the MySQL shell to our existing MySQL databases. And based on the MySQL shell, we dump the data and we dump it directly into the so-called OCI object storage. Once the data is in the object store, we can import the data in a third step directly towards the MySQL Database Service. We've got dedicated webinars and tutorials for this in case that you're interested in the specifics and the various configuration options. Should not be a big thing. Let's talk a bit about service availability and data durability in the Oracle Cloud. In this example, we are running a MySQL service in one of the server fault domains, which we discussed at the beginning of this presentation. We are replicating all MySQL data on the block storage automatically, so that it is available in all 3 fault domains. This means that in case that the MySQL server is going down, for example, because of hardware failure, it will automatically, or it can automatically be started in another fault domain based on the replicated block storage. So by default, we're doing a daily backup of the MySQL instance. This backup is not just stored in the availability domain, but it's also replicated across the region itself. So it is available in this example also in the availability domain 2 and in the availability domain 3. This means that you can easily start a new MySQL service. It's not an automatic process, it's a manual process, but you can start a new MySQL instance based on the restored MySQL data from the availability domain 1. So that even in case that the availability domain 1 is going down for whatever reason, you can continue in the availability domain more or less right away based on a backup process. In case that you have a request for higher or more service availability, we are offering an automatic HA service on top of the MySQL database service as well. For this, we are using MySQL Group Replication, which we offer since MySQL 5.7, I think back in 2015 or so. It is the same technology which you may use in your on-premise MySQL setup when you're using MySQL Group Replication or InnoDB cluster. For multi-availability domains, we are spreading the MySQL instance across the region. For single availability domains, we are spreading the service across the fault domains. Unlike InnoDB cluster, where we have a dedicated MySQL router component, we are using a router from the Oracle Cloud Service. It basically does the same job. It routes the connection to a primary server, a primary MySQL instance within the MySQL cluster. Our whole HA story is seamlessly integrated into the MySQL service and can be easily used without deep knowledge of group replication or of InnoDB cluster. It provides no data loss in case of a failures, an RPO time of 0, and offers online and fast failover and RTO time of less than 2 minutes in case of a server outage. Enough slides now. Let's go to the live demo and let's have a live look into the MySQL Database Service. So let's do the short demo here, right? So first of all, you need to log into your tenancy. My tenancy is called the MySQL SE tenancy, and I'm just logging in with my credentials. The tenancy is provided as part of the setup of the cloud account, so for example, as part of the $500 vouchers, which you hopefully are going to use and to test the Oracle Cloud. Then you will see the dashboard. You only see a portion of the desktop, but it really doesn't matter here for us, right? The first thing what you probably want to do is you want to set up a cloud network, right? So I've done this already. It's called VCN, Virtual Cloud Network. And I started a virtual cloud network, which is called Carsten T VCN Frankfurt. I'm used just the wizard. Well, just do it. Takes about a couple of seconds, basically, right? And the only change what I've done as part of the virtual cloud network is the security settings, which we will look at in a second. Another point which you probably recognize is that I am in the compartment. You probably remember the concept of the compartment from early on, where I said, look, a tenancy is basically divided into compartment, which is basically a logical combination of resources in the Oracle Cloud, including the necessary privileges. Let's go to this virtual cloud network environment, and you will probably recognize that in the security list that there is a small change which you need to do, or what I would recommend to do. So I added 2 lines here in the security list to ingress rules, one for 3306 and the other one for 33060. I assume that you know a bit about MySQL and you know that those are the default ports. So this basically means that in my class Z network 10.0.0.0/16, I can easily connect in between the availability domains to my MySQL database service. Again, just do this for 3206 and 3260 based on your IP address. You can restrict it even more. In my case, it's sufficient to restrict it to 16. Let's switch to the core MDS service now. So the core MySQL database systems is divided into 4 sections where you can configure and when you can administer your MySQL database systems, right? The database system itself, right, that's just a list of the database instances which are either up and running, which are stopped, or which you're deleting. The backups is just a place where you will see all your backups of your instances. In my case, I do not have any backups, no problem here. Channels, remember that we talked about inbound replication early on. So in case that you want to replicate your on-premise MySQL version to the MySQL database system, that's something what you would do here. And configuration, that's basically a my.cnf setting. So you can specify, you can configure a customized my.cnf settings for your application needs, which at the end it's leveraged by the database system, which we want to start from this place here. Let's create a MySQL database system here, right? So I would like to configure a MySQL database systems in my own compartment. That's fine. I will leave the standard name, which is just the creation day plus the MySQL, and with the description I just add, this is a test to make it as simple as possible. Then you already see the next option, which again, we talked about this during the slide, should be rather straightforward. Standalone box is a single instance of MySQL. High availability means that we are automatically rolling out 3 instances of MySQL within a region. In Frankfurt, it would mean that it would be available in availability domain 1, 2, and 3. The administrator needs to be specified here. Again, I think that is rather straightforward. So leave the admin and the password. And within the MySQL database system, you can configure the used network. We only have one virtual cloud network here, so the Frankfurt one. So I have to use this one. And based on the subnet within the virtual cloud network, you're specifying where the instance should be executed. So I can select it should be executed in subnet 1. It would mean that the instance would run in availability domain 1, and the other way around. In case that I change it to 3, it will be executed in availability domain 3. In addition, you can choose the default domains. Again, I really don't care where it is running, so therefore I leave the default domains open. But I do not want to use the smallest possible instance of MySQL, but in fact, I would like to use a bit more memory here. So I'm selecting the one OCPU with 16 gigabytes of memory. And again, 15 gigabyte storage size is probably a bit small for me, so I'll probably go for double the size, 100 gigabytes here. Yes, I would like to use the automatic backup scheduling, and yes, a 7 days retention, that's pretty much okay for me, but I would like to choose the backup window. In my case, I would like to do the backup at 3 midnight, 3 o'clock UTC in the morning. And in case that you would like to configure more advanced option, right, you can specify in case that you've done the configuration in the MySQL database section, the configuration section already, it would be available here and you can select it. We've not done it, so therefore, right, we cannot really change it. Management basically means the maintenance window, the maintenance period. Yes, I would like to do the maintenance window and I would like to do it again after my backup in the morning. So let's say I'm going for 5 o'clock in the morning, 5 UTC time, and the maintenance period should be on Sunday. So from a network perspective, you can specify a host name, you can specify an IP address, I really don't care, and you can specify different than the default ports, 3206 and 3206. Oh, again, I'll leave them as they are, and you can use tags for my MySQL database system here as well. Again, I don't care, so therefore I leave it as it is, and I press the create button. And that's basically it. That's everything what you need to do to configure the MySQL database service. In case that you think, well, that's looking nice, but I need a more automated way in setting up the MySQL database system, yeah, that is available as well. You can use the Oracle command line interface, for example, as well for doing automatic scripting, for integrating it into Python and other stuff. And yeah, you can use other technologies like Terraform, for example, as well. The database creation system takes about, well, 8 to 12 minutes, depending on when you do it and where you do it. But I will probably stop here for a second and I will come back once my service is available. So there we are. The MySQL database system is up and running. Took about 9 minutes or so. You will see a summary of the installation in the database instance itself, right? You remember that we've not specified a specific host name or a specific IP address, but in this case, you can connect to this instance based on the IP address 10.02.234. Further down, there are a couple of metrics which you can use to monitor the MySQL database, but you probably have seen that it is rather straightforward. It's rather simple at the end, and this is the whole idea of the MySQL database service. It should be as simple as possible, but still we do provide a couple of advanced options like HA or inbound replication. In case that you're interested in further details, again, don't hesitate to get in contact with us directly. So this was the first part of my presentation. This was about the MySQL database service. We are here to help. In case that there are more questions, feel free to ask. It would be great when you can join the second part of this presentation as well. This is about the MySQL HeatWave technology, which is an analytics engine which you can use on top of the MySQL database service. Again, would be great when you can join. Have a great Percona Live. Have a great day. Thank you very much for attending. Bye-bye.